Okay, so today we're going over slope of a line. So this takes us into Unit 3, which means we're halfway done with the end of our lessons. There's only 6 units in this class. So slope of a line. So rate of change. So the rate of change of a function is the ratio of change in the dependent variable with respect to change in the independent variable. So how the x values change compared to the y values. And that's how we get this equation right here, where you have your y2 minus y1 over x2 minus x1. Your x1 and your y1 are going to be your coordinates for your first point, and then your y2 and your y1 are going to be the coordinates for your second point. And basically, you're just looking at the ratio between those two differences. So, for example, here we have a graph, and this says the graph shows a biker's distance in kilometers over time in hours. Find the rate of change. So basically, the way you find the rate of change is you want to find 2 points on the line. So for this example, it uses point 1 and 15 and 2 and 30. And basically, we're being asked to find the rate of change. So you take those two, and basically you plug them into the rate of change equation. This is your x1 and your y1. This is your x2 and your y2. You plug that in, and you get the following equation that you see here. 15 minus 0 is 15. 1 minus 0 is 1. So basically, you're just doing 15 divided by 1, which is 15. So that means the rate of change is 15. What this tells us is that the biker travels 15 kilometers per hour. All right, any questions about this? Questions, concerns? No? Okay. We also have what is known as the slope of the line. The rate of change is also called the slope of a line. So basically, we find the slope whenever we have a linear function and we want to find the slope of that line. It is the ratio of change in the dependent variable with respect to the corresponding change in the independent variable. Very much like rate of change, you basically use the same equation. Slope is also sometimes called rise over run, where you just identify how the rise acts in relation to the run. So for example, say that we have this problem right here, or this graph right here, when we're asked to find the slope. Well, all we have to do is do the same thing. You just find 2 points on the line. In this one, we use 0, 0, and 2, and 1. Give your x1 and your y1, your x2, and your y2. You plug that into the slope formula or the rate of change formula. What you get is 1 minus 0 is 1, 2 minus 0 is 2. You divide 1 by 2, you get 0.50. So basically, this says the rate of change is 0.50, which basically means that the cost is 50 cents per pound. Where in this, we're looking for how many pounds you have of lemons affects the cost. Okay. We can also take the slope of a table like you see here. This one says Jonas loans his sister $67.50. She pays him back with her allowance each week. The table shows how much is still left on the loan after the first 4 weeks of repayment. So basically here we're able to find the slope. Well, basically you just want to do the same thing. You want to identify 2 points on the table. So here's my first 2 points. Here will be my second 2 points, and you want to see how those relate to each other. These are my x and these are my y's. So this means this is my x1, this is my y1, this is my x2, this is my y2. I plug that in and I see that I have 51.75 minus 67.50. which is negative 15.75. I have 1 minus 0, which is 1. So basically, I'm taking negative 15.75 and dividing it by 1. So that gives me negative 15.75. So what this is telling me is because my slope is negative, it's telling me that Joan owns her brother Jonas $15.75 less each week. So if she's paying off the loan, obviously the amount she owns is going to decrease. So basically, every week she owes a little bit less, right? Any questions about this? Questions, concerns? So again, this is just what is known as the slope formula. The slope of a line can be calculated using this formula. M is representative of the slope. So whenever we see M, we should think of slope. And basically, we find the slope by doing y2 minus y1 over x2 minus x1, where x1 and y1 and x2 and y2 are points on that line or points on that table, depending on what type of graphic organizer we have. So here's just another example of how we can apply the slope formula. Say we're asked to find the slope of the line that passes through these 2 points, and we're given these 2 points. Well, in this instance, we're given those 2 points. So all I have to do is plug them into the slope formula. So this will be my x2 and my y2. This would be my x1 and my y1. I just plug those in, which gives me 6 minus negative 4, which is 10, and negative 2 minus 8, which is negative 10. 10 divided by negative 10 is negative 1. So basically, my slope is negative 1. All right, any questions here? So in this instance, you're actually given those points. You don't have to identify them on your own. And basically, you just plug them into the slope formula to solve. What you'll eventually notice is that we can have 4 types of slopes. So we can have a positive slope, a negative slope, a zero slope, or an undefined slope. Whenever we have a positive slope, the slope moves up from left to right. So what you'll notice is as the x values increase, your y values also increase. So that would be a positive slope. The negative slope, on the other hand, goes from left to right. So as your x values increase, what you'll notice is your y values will actually decrease. Then you have zero slope, which often looks like a horizontal line. And basically this means as the x's values change, the y value will stay the same, like it won't change. And then lastly, you have undefined slope, which is just a vertical line. And this means that as the x values change, the y values don't change, they stay the same. So these are the different types of slopes that we have, and we'll look at these a little bit further. So another unique thing about these types of slopes is that whenever you have a positive slope, you'll actually get a positive number as a result of finding the slope. So you'll plug your points into the slope formula, and you'll get a positive number. Here you have a positive 5, and so you'll know you have a positive slope because you have a positive number. Well, when you have a negative slope, you'll get a negative number. So when you plug this in, what you'll get is a negative number. So negative 25 minus 4 is actually negative 6.25. And that's a negative number. And because it's negative, we know we have a negative slope. How about zero slope? Well, whenever you have a zero slope, what you'll actually get is a slope of 0. So you'll plug those 2 points in, and you'll see that your resulting slope is 0. So now you have a zero slope. And then lastly, undefined. Here, you'll see that the slope is an undefined number. So basically, you can divide 6 by 0. And so when you actually plug that into the calculator, you'll get something that says undefined, and you'll know you have an undefined slope there. What you can also do is you can differentiate these by the way or the characteristics that we looked at. For example, as the x increases, the y also increases. As the x increases, the y decreases. As the x increases, the y stays the same. And here, as the x doesn't increase, but the y changes, the y increases. Okay, also by the way that they move up, here you go from left. Here you go from left to right. Here you go from right to left. So all these different characteristics, here you have horizontal. And here you have vertical. So there's different characteristics for these different types of slopes, and we can use these characteristics to be able to define what type of slope that we have. Pretty straightforward, right? Okay, any questions about anything that we went over today? A lot of this may have been reviewed, but does anyone have any questions? No? Okay, so we learned that we know what rate of change is. Rate of change is basically how the dependent variable changes in response to the independent variable. Rate of change and slope are interchangeable terms. Sometimes we refer to slope as rise over run. It just kind of depends. But basically, the way we find the rate of change or the way we find the slope is the same. We use this formula right here. And we get our x1 and our y1 depending on certain points on the line, and our x2 and y2. And then, like we just discussed, lines can be represented as positive slopes, negative slopes, zero slopes, or undefined slopes, depending on how the x and y values are related to each other, or the slope that we get. If we get a positive slope, we have a positive slope. If we get a negative number, we have a negative slope, so on and so forth. Okay? Any questions about anything we looked over today? Questions, concerns? All right. Like I said, today's super brief. We'll go over some practice problems tomorrow, but if there's no other questions, you guys may log off, and I'll see you guys tomorrow. Bye, guys. Bye, YouTube.